Hello everyone, welcome back to PMAT1100. So in this video we will be starting our new unit number 3, and we'll be starting with section 3.1. In section 3.1 you will be introduced to a new concept, and this concept you will be learning how to compare one quantity to another type of quantity by setting up ratio. As you know, in previous section you learn how to compare one quantity to itself by create a relative change, right? And that comparison is in percentage. In this video, in section 2.1, we compare one quantity to another quantity by also create a fraction, a ratio. However, that ratio we call that the rate. Okay, and on the second part of this video, we will learn to compare one quantity to another quantity by set up the ratio between the change of the first quantity and the change of the second quantity. We call that rate of change. Okay, so let's get started. So section 3.1. So I'm gonna put over here is the topic will be rate of change. Okay, rate of change. There you go. So what is rate? Let's talk about that one first. What is rate? First Roman, rate. Rate is actually the ratio between one quantity, a ratio of one quantity to another quantity. Okay, is a ratio. Okay, that compare two quantity. Okay, I can say like that. That compare. Okay, I think I need to change the direction a little bit. That compare two quantity, or literally it is the fraction between one quantity and another quantity. Okay, I can say something like this. Because it's a ratio, it's a fraction, right? It's a ratio, it's a fraction. So I can set up a fraction like this. So over here I have two quantity. Okay, I have two quantities, something like this. How about this? I am making $500. Okay, I'm making $500 for 2 days. Okay, so the first quantity is 500, the second quantity is 2 days. So I can set up the ratio between the first quantity is 500. So the rate, I can set up the rate something like this: 500 over 2 days. Okay. Okay, and this is the rate. This is the rate. However, you see that 500 over 2 days, if we simplify it, the fraction, so it will be what? Will be equal to 250 over 1 day, right? Okay. So if the bottom is 1, okay, if the bottom is 1, it's not just the rate. We call this so this one over here, we call, let me use different color for that. We call that we call the unit rate. Okay, so over here is unit rate, because the bottom, the denominator is 1. The denominator is 1. Then we call it unit rate. Okay, then we call it unit rate. So these two rate over here is, when we set it up, this is the same. All right, this is equivalent. It's the same. It's equal to each other. Okay. Or I can give you another example. How about something like this? So this is example 1, example 2. I'm driving. I drive. Okay. 60 miles. Let me erase. So I ride 60 miles. Okay, for 4 hours. Okay, 60 miles for 4 hours. Okay, so then I can set up the rate is 60 miles over 4 hours. Okay, then if I simplify it, so this is what is the rate already. I can simplify this so that it become unit rate. So will be what? Will be 60 miles for 4 hours, and it will be equal to 15 miles for 1 hour. Right? So this is the rate, but however I can simplify to the unit rate. So this is also a unit rate. So this unit rate. Okay, so this unit rate. Okay. Every rate can be changed to unit rate if you want to. Okay, if you want to. I need more space. All right. Okay. So these two fraction here actually is equal to each other. Okay. So that is what rate means. That's what rate means. Pretty simple, right? Or I can do something like this. Example 3. A runner jog, okay, 1 lap around 400-meter track. Meter track. Okay. In 2 minutes. in 2 minutes. Okay, so that it mean what? It means that every 2 minutes he runs 400 meters. Okay, so we can set up the ratio, the rate. Okay, we can set up the rate. Okay, we can set up the rate like this: 400 meter. Okay, over 2 minutes. Right. Okay, so this is the rate. Or you can write like this. It will be 400. Let me write it in the unit. So this meter over 2 minutes. Okay, that's the unit. Okay, and you can convert it to unit rate. So it will be 200 meter per minute for 1 minute. Unit rate, it means the bottom must be 1. So for 1 minute, so this is unit rate. Okay, for 1 minute he runs 200 meter. Okay, so I'm gonna put over here this unit rate. Okay, all right. The question can be asked more, something like this. What if they ask you how far he runs for 1 second? So what you're gonna do? Okay, for 1 second. So you need to use the concept we had last time in the previous video. We learned how to convert unit. Okay, so question. So this is the rate. Okay, this is rate. Okay, so the question is how far does he run for 1 second? Okay, okay, so 1 second. Okay, so we know the relationship. Okay, we know the relationship between a minute and second is that 1 minute equal to 60 seconds, right? Everybody know that. Okay, okay, so we want to change to second. Okay, so it will be 60 seconds. You multiply by let me see, 60 seconds. So you multiply by the minute. So, or I'm sorry. So this is I should erase this. So we know we set up the conversion factor, right? So we know that because we need to change the minute and we keep the second, so we know that it's 60 seconds 1 minute. Okay, so this is what we need to change, because we need to change to second. Let me see. We know that okay, 200 meters. So we know 200 meters. Okay, for 1 minute. Okay, and oh yeah, so we need so this is because we have two, we always have two conversion factor, and because we want to cancel the minute, so I think we should keep we should have something like this. The minute should be the top. Okay, so 60 minutes. Okay, because the minute on the top, then you have second at bottom, so it works. So right now you see that you can cancel the minute, right? 1 minute, 1 minute, 200 meter per minute, 1 minute. Oh yeah, I think I messed up a little bit here. So 1 minute, I said 1 minute. 1 minute is 60 seconds. So here you go. There you go, like that. Sorry. So this is a conversion factor we use. 1 minute is 60 seconds, right? We can write 60 seconds over 1 minute, but I mean, when we write 60 seconds over 1 minute, then we cannot cancel the minute, right? The minute should be on the top. Okay, so you multiply by this. Then you have 200 meter, okay, over 60 seconds, right? So this is the ratio in second. This is the ratio. This is the ratio. This is the rate. This is rate in minute. This is the rate. Okay, this is the rate in minute. This is unit rate in minute. This is the rate in second, but it's not unit rate. So we need to convert it to unit rate if you want to, if the question asks you to convert to unit. So 200 divided by 60. So what it give you? About 3.33. Okay, 3.33 meters. I'm sorry, 300 per second. Okay, or you can write like this: 3.33 meter per second. Okay, so this is unit rate. This is unit rate. All right. This one is unit rate in minutes. So this is unit rate in second. You can write like this, but most of the time we write like this: unit rate in second. And this is unit rate in minute. All right, everybody clear? Okay. All right. Okay, next question, they can ask you like this. So this question 1, let me change it to white color. Question 2, they can ask you, what distance will the runner cover in 40 minutes? What distance does he cover in 40 minutes? I should change it to 4. Okay, for 40 minutes. Okay, so we know that 200 meter he cover for 1 minute, right? So 200 meters for 1 minute. So now for 40 minutes, okay, so you just need to multiply by 40 minutes, and in doing so, see that you can cancel the minute, and what you have left is just meter. So totally is 8,000 meter. Okay, 8,000. So one problem might have like several sub questions, and I can ask you something like that. Okay, and you can do the same if it asks you what distance he cover in for 40 seconds. So you just need to multiply this one by 40. Okay, because you know that 3.33 is a meter per second, and 40 seconds, 2 seconds will be double. So 40 seconds you multiply by 3.33 multiplied by 40. We already learned this when we talk about multiplication. Okay, I believe in section the unit number 1. Okay, all right. So that's what the rate is when you compare one quantity to another quantity. And now if you compare the change of one quantity to the change of another quantity, then we call that rate of change. It's not just the rate anymore, but it will be the rate of change, because we compare the change. Okay, we compare the change of two quantity. So on the second Roman, I want to talk about rate of change. Okay, so rate of change is actually the rate between the change of first quantity to the change of the second one. Okay, rate of change, sometimes we call that the slope. Rate of change is actually the slope, and the slope is the change, because this is the rate of, is the rate, right? So the slope is also the rate, it's a ratio. Okay, so it's the ratio. Okay, it's a change in y variable over the change in x variable. Remember what y mean, right? Y is dependent variable, x is independent. Okay, so the change in y, we can write it as I can whatever you have, the first y and the second y, so the new value and the old value of y. So I can name it something like y2 minus y1. Okay, so this is new value, this old value. Okay, over x2 minus x1. Okay, so I want you to memorize this formula. Okay, let me use this color. Alright, so make sure you memorize this formula. That's what the slope means. Okay, it's the rate of change. Okay, alright, let me give you the example. How about we have something like this? Example. Okay. Hopefully I have enough space for this. So I have a table of data. Okay, I have a table of data, and well, this table of data is based on the following information. Okay, so I'm gonna hopefully I have enough time to graph based on I give you a graph based on this data. Okay, so I have a question like this. According to okay, taxi fare finder.com, a cab drive from airport. Okay, arrive from airport in Vegas. Okay, in Vegas. Okay, will cost you initially charge after you do the example. You will know two more terminologies, very important. $5 and 10 cents. Okay, plus 2.6 plus $2.6 per miles. Look like they give us the rate, right? It look like they give you the rate. Okay. Okay. The question is, use this information to set up the table for the total cost. Okay, so first question, use that information to set up table for total cost at various distance Okay, so that's the first question. Okay, let's set up the table. Okay, see, I don't have enough space, so I need to jump to another space, another page. Okay, so I have the table like this. So I have the table, and oops, not a nice one at all. So I have a table like this because they want us to set up the table. So over here I have distance. Over here I have cost, right? Because I set up the table for total cost, and we just do few of them. So we do distance 0 miles, and we do 1 miles, 2, 3, 4, 5. So this one we just need to do 5. Well, you can do more, but I don't think that's the reason we need to do more, because the 5 value is good when you do this. If you want to graph it, you want to sketch it, 5 is good. So you see, initially we have $5.10, right? So that's the initially you have to pay. Then they say that $2.6 per miles. Okay, it means that on the first mile you pay how much? $5.10 plus 2.6, right? 2.6, right? Then the total you have to pay will be what? $7.7, right? And you do similarly for all of them. Okay, so let's calculate 2 miles and see how much does it cost for 2 miles. Okay, so for 2 miles, so we still have initial prices $5.1, and for 2 miles you're gonna do because $2.6 for $2.6 per mile. So for 2 miles you multiply it by 2. Okay, so 2.6 times 2. Okay, then you will have, I'm sure you will have, if you calculate amount, will give you a $10 and 30 cents. And for 3 miles you do the same thing, but you multiply by 3. Okay, then you have, if you use calculator, you have $12 and 90 cents. 4 miles. Okay, 4 miles you multiply by 4. Okay, then you will have $15 and 0.5. And for 5 miles you multiply it by 5. Okay, I can do a quick check. Yes, and look like it's $18 and 10 cents. Okay. Alright, so this one over here is the x variable right here. So this is the x variable. So and the cost is y variable. So so it depends. The cost depends on the distance. Okay, how many miles you travel. So this is y variable and this is x variable. Okay, so you can draw the system, you can draw the graph using this data. Okay, so let me get the coordinate. Okay, let me get the coordinate. I had a coordinate like this. Well, I can have a coordinate like this because you don't need my negative value, so I can have a coordinate like that. There you go. So I have a coordinate like this. There you go. And you see that this coordinate here, there's no increment, there's no value on it, but we can put the value on easily. Okay, so we see that the highest one you get is $18. So this is the y one, so I'm gonna just use I'm gonna just extend a little bit more and make sure this is y. So y is the cost, and we have this is 1 2 3 4 5. This is easy, this is only 5, so this is the x. So 0 right here, so you have 1. Okay, make sure you have equal increment 2, 3. I try to be perfect. 4 and 5. There you go. And we have first of all, when you have 1 is $5. Again, I'm gonna divide it by, I think I'm gonna divide it by 2, right? It should be by 2. It's good. Or you can do by 5 if you want to. Yeah, I think by 5 is good too, because it's 18. I think let's do by 2. So 2, 2, 4, 6, 8, 9, 10, 11. Yeah, let's do by 2. I think it's more accurate. So the increment here doesn't have to be the same as the increment here. I mean the distance. However, on the same axis, it should be the same. Okay, it should be the same. So I can mark over here is 1 here. Over here is 2, 3. I don't know if I have enough space for that or not. 3, 4, 5, 6, 7. Probably I don't have enough space. 8. So 8 here. 9, 10, 11, 12, 13, 14. Oh wow, I don't have enough space. I think we're gonna erase it. So let's let erase that and put the number again. Okay. It's easy, but it just took a little bit of time. So over here is 2. I'm gonna write really small. 3 here, 4 here, 5 here, and 6 here, 7 here, 8 here, 9 here, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Here you go. Okay. Alright, so for the first one we have a 7.7. So let me use a different color. So let me use this color here. Okay, so we have 510. So for 0 we have 510. So 510 is around, so 510 is around right over here. So we have the first point is here. We just estimate, okay? So this is the first point, 510. Then we have 2 is 1030. 2 is 1030. 2 is 1030. So 2 right here. Okay, 1030 is around that much, right? So if we draw this point like that. So 1030 is around that much. So the second point is here, right? Hopefully I have enough space. So 3 is 12. 3 is 12. 3 is 12. So 12 right here. Okay. It's not really perfect, but I try to be perfect, you know. Yeah, because right here it look like there's some error already. So let me try to be perfect here. Okay. So we have around like this. Okay. And 4 we have 15.5. So 15.5 is around that much. For 4. Okay. So right here. And 5 is 18.10. So here you go. This is for 5. And you see that if you connect all the points here, what it give you? If you connect all the points, it should give you a very beautiful line. Okay, very beautiful line. Oh, very beautiful. Here you go. It's a straight line right there. Okay. And you see that this straight line here, it intersects the y value at a point right here, right? And this point over here with coordinate is 0, 5.1, right? Okay. This point here we call the y-intercept point. Okay, y-intercept point. So y-intercept point is actually the intersection point between the graph and y-axis. Okay, so I can write the definition of that. This is the intersection point between the graph and y-axis. Okay, that's the definition of y-intercept point. So if you look at this line, you see it's only intersecting the y-axis. It does not intersect the x-axis. But if you have another graph and if it intersects the x-axis, then we call the x-intercept point. Okay, so for this graph we don't have x-intercept point, but I can draw you the definition of x-intercept point. So x-intercept point is intersection point, okay, between the graph and between a graph and x-axis. My graph here, there's no x-intercept point. Okay, no x-intercept point here. Okay. So over here, I'm gonna put over here is the distance. So because x is the distance. I don't need to put for y because you know y is the cost. Alright, so that's the graph. And that's the definition of x and y intercept. Okay. Alright. Now what if I want to find a rate of change? I want to find a rate of change of this data, this graph. So how are we going to find that? So how we find the rate of change? In order to find the rate of change, we're going to pick any 2 points on the graph. Okay, any 2 points on the graph, because I can name any point I want, right? You can name this is point A here. This is point B. This is point C. This is point D. Okay, and the last one is point E. Okay, so I'm gonna pick 2 points. Okay, I'm gonna pick 2 points, and I will do the rate of change. Okay, so I'm gonna pick the first point. I think I'm gonna pick point A. Okay, any point. Okay, I'm gonna pick point A. Okay, point A with coordinate is 0, 5.1, and point B is 2 and 10.3. So I pick those 2 points. Then I can find the rate of change. Okay, is remember the rate of change, we already know that this y2 minus y1 over x2 minus x1, right? The problem that you don't know which one is y2, which one is y1, so we need to label them. So you can, if you put this is the first point and this is the second point, then this will be y2 and y1 here, and this x2 and x1 here. Okay, you can put A as the second point and B as the first one. It's fine. Okay, it doesn't matter. You can pick any point first. That's okay. But usually I always pick the second one as the second point. You know. So the B as the second point. So we're gonna plug it in. So we have 10.3 minus 5.1 over 2 minus 0, right? Okay, now if you put that in the calculator, so 10.3 minus 5.1, it gives you 5.1. It gives you 5.2 over 2 divided by 2. Then you have the rate of change will be 2.6. Okay, so that is the rate of change. Very easy, right? Very easy. Okay, actually you see the difference. If they sometimes they ask you this question before they asking you rate of change. Sometimes I can ask you that what is the difference between like the difference of the cost. What is the difference of the cost between the second mile and the third mile? Then you just subtract the y component here. Okay, I can ask you like that. Okay, but this rate of change is also the slope. We already know that, right? So the rate of change is the slope. Okay, and I just want to add one more information. It's good to know this. If the slope, because you see over here the line is kind of increasing, right? It's slanted upward. So if the slope is positive, then the line is slanted upward. Okay, and if the slope is negative, so I'm sure that some of you already know this because in high school we learned this. It's slanted downward. Okay, so this is I put it as remark because this is kind of important information for you to know, because what if your graph is slanted upward and when you calculate the rate of change, the slope, and it turned out to be negative, it means you know right away there's something wrong with the slope. Okay, so this is important. It's important. All right. All right. Oh, all right. Very good. Very good. Alright, so I think that's all for this section. Pretty good for the start of new unit, section 3.1. Please go ahead and scan over one more time and make sure you understand it. If you don't, please let me know. Other than that, I'll be seeing you next time in the new section. Bye bye.